Chapter 13, and I believe you guys have problem 2, and we'll take a look at number 1, which is similar. And we're talking about correlations here, and as we move on, we'll get into some linear regressions. When you talk about statistics, you almost always have to talk about regressions, and so now we're interested in looking at if there's correlations between sets of data. And these can be fairly important, and correlation doesn't mean causation, but if you were to do a study, say, on the impacts of school spending, is there a correlation between school spending and student outcomes, right? And you could chart that, and you could determine that as long as you had some data, right, in order to come up with that. And so I find correlations actually to be kind of intriguing, and I do use this one, not so much in work, but in other aspects of life. I find it kind of interesting to compare data sometimes. So in our case, for number 1, we're given some data, and it's in a data set. I was able to download, and they had it in the book. It's in rows, and here when I downloaded it's in columns, and so I've gone ahead and just downloaded in the columns. And you could do this either way, and it tells you to go ahead and calculate. And I want you guys to do this the long way. Okay, calculate what the correlation factor is. You can do some of it the long way. I'll let you cheat a little bit, but calculate what the correlation factor is, and then make a statement about that actual correlation factor. So here's my data, right? And then we do something similar like we do if we were to calculate a standard deviation or a variance, right? And first we figure out a mean for each of our sets of data. So for X, I would come here and simply do the average, right, of that group of data. And I can just draw that over. Okay, and then you do what we would do, find a variance or a standard deviation. This is equal to this minus my mean, and let's put the dollar signs there. Okay, and by the way, this formula is in the middle of page 433, the correlation coefficient. And as you read that, the R is the value that we look for, that we call the correlation coefficient. And as you read that, what that means, it's the sum of our X minus the mean of X times Y minus the mean of Y divided by N, okay, N minus 1, which is the number of data in our set, minus 1, times the standard deviation of both X and Y. So onward we go then. We can simply do that. It should be equal to 0. If we total that, that's just kind of a little test, I guess. You don't have to do that. And this then is equal to this one minus, or this one. And again, use the dollar signs and do that. Okay. And then again, according to that formula in 433, it's those multiplied together, right? X minus the mean of, Y minus the mean of, then we multiply those together, so simply equal to this one times this one. Okay, and that would then we can also just drag down, right? Okay, and so we've done that, and then we just need to add those. Take the sum of those. I don't know that we need the sum of, yeah, because it's, so the sum of that. Okay, so we get 10.6. Now the next one, this is where I'm going to let you cheat a little bit, because we could go along and calculate the standard deviation of each of these. You guys would know how to do that, right, by squaring each of these and going through that whole process. I'm going to show you something a little more simple, and it's going to give us this kind of output down here. And I'm going to I'll delete this now and see if I can recreate it. Hopefully I can. Let's get rid of that stuff there too. So let's go up to our data and our data analysis, and you find the one that says descriptive statistics. Man, you guys could have used this earlier. Okay, hit OK, and it asks for the input range, and in this case, just capture the data. Okay, and I went ahead and captured the labels, and you don't have to, but if you do, make sure you click labels in the first row, and you also need to let it know whether it's in columns or rows. So if we'd have input this data in rows, that would have been okay. We just need to tell it that. And so my data is okay, and boom, that's okay, that's okay. So I want my output range. Again, I have to be kind of careful here. I'll put it there. And then you got to make sure that this one here is clicked, the summary statistics. We don't need a confidence level in this case because we're not looking for a confidence level. We're just finding some statistics here, some data that we're going to use otherwise. Click OK. And that gives us this bit of information, right? It gives us quite a bit of information, right? The means, the standard error, the median, the mode. There isn't a mode for that one. The standard deviation of each of our set of data. It's kind of cool, actually, isn't it? The kurtosis, which we'll talk about, the skewness, which we have talked about, on and on. Pretty cool. Pretty cool. Okay, and so if you look at the bottom then, it's our n minus 1, right? And our n, we have to do a correlation, you have to have equal sample sizes, and so we're going to do the sample size for 1, I guess you could say, or any of the 1 columns or rows of data that we have. So we got 1, 2, 3, 4, 5. Okay, and so I got 4. It should actually be, it's equal to, all right, n minus 1. We ought to put 5 minus 1. You guys could do that math in your head if you wanted to, times, and it says the standard deviation of x, x, standard deviation, wow, times the standard deviation of y. So here's my y, standard deviation. It's too easy. Hit my enter, and there I have it. Okay, I have that. Okay, but then I have to divide these. Okay, remember, this is the top part of that equation. This is my sum of. Okay, that's why I got to that 10.6, right? That's my sum of, and this is the bottom part of the equation. So now I have to divide those. So I simply say this is equal to this one. Oops, better hit the right symbol divided by that one. And there you go. So I end up with 7.752246. Okay. Are there easier ways to do that? Well, maybe. Well, maybe. Let's go see. Okay, so here's your test. You did it. Okay, let's make sure you got it right. Come to data again, data analysis. Let's go to one that's called correlation. Hit OK. Again, capture my data, label. Okay, in this case I'm going to move my output range to here, and I think I'm okay. Okay, so what I'd like to do then is highlight this one. Okay, and you could highlight this one as well, just kind of showing that those are the same answers. A lot of stuff there going on for just a little bit of data, but some pretty cool tools that we have as well. Thanks, and there's number 13.2.